Okay, welcome back. So now we're going to talk about education. Let me quickly share my screen. When we think of education, as I said earlier, so we have two particular way of increasing our human capital. One is schooling, and the other is on-the-job training. Okay, we can both call them education in general. And let's try to understand some particular aspects of education. So for now, let's talk about, let's think of some parents, okay, who will obtain utility from their consumption, utility from the number of their kids, and also the human capital of their kids, okay? So consumption will be adults' consumption level. Okay, and T is the number of children, and HT plus 1 is the human capital of each child. Now, obviously, human capital will be created by education spending. This is the simplest model you may imagine, or one of the simple versions of a model. So here, ET is education spending for each child. And HT, of course, is the human capital of the parent. Human capital of adults, let's say, right? So you have one equation, which is the utility function, another equation, which is the human capital production function. So this can be called human capital production function. And of course, time here indexes generations, right? So we can imagine something like this. So this is called overlapping generations. Okay, overlapping generations. So you can imagine something like this. So at t equals 0, okay, there are some adults here. Let's say their number is equal to NT, okay? Then these adults have kids. Let's say they have NT kids. So at the end of this period, adults die and kids become adults. Then there is t equal 1. At t equal 1, these kids become adults themselves, right? So they have kids, so then they die, and their kids become adults at t equals 2, right? So there's overlapping generations of people. So the last thing to consider before solving this model, and you understand that I am trying to formulate an optimization problem here. The last thing to consider is, of course, the budget constraint, right? So there will be a budget constraint where the adult pays for consumption and he or she also pays for the education of their kids, okay? And also, you may imagine there's a cost of having kids, right? So let's suppose that this cost is constant for now. Okay, so for each kid, you have to purchase kappa units of the final good, let's say. Now this thing will be equal to wage, right? Earnings. Now these earnings could be depending on some base wage rate. So let me have some space here. So W is the base wage, and kappa is some cost of fertility. Okay. Now, as you see, this is a model of quality-quantity trade-off, right? Why? Because the parents, the adults, face a trade-off. So they obtain utility from their consumption, they obtain utility from their kids, just the number. So this is the quantity part. And they also obtain utility from the quality of their kids. Okay, but for quality, to create educated kids, to create skillful children, they have to spend something on education. Okay, and also the kids benefit from educated parents. Okay, so there is an externality here. So parents' education is important for kids' education. Okay, parents' human capital is important for the kids' human capital. And then there is the budget constraint. Okay, now if you solve this model, so if I give you an explicit U function and an explicit F function, you can actually solve this model as long as there is some concavity restrictions, as you know, right? So this is just a microeconomic view of fertility and education. Then you would realize we should also introduce the time cost of fertility, okay? Now, you can understand it even better with rho positive, okay? Now, what I did is this. So this becomes labor supply. Remember, last week we discussed, it was last week, right? We discussed the quality-quantity trade-off, but we also discussed income effects and substitution effects. Now, when I put the time cost of fertility here, I say if the parents have more kids, if N is larger, then labor supply is lower. Okay, so this creates a cost of fertility in terms of lost wage income. Okay, so then if you can solve this model, you would realize the quality-quantity trade-off is active, okay, which means if you get richer in terms of human capital, then your fertility should decrease. Okay. In general, in such a model, we are interested in the share of education spending in the total income. Okay. So this is a nice indicator. I have a paper that uses a simple model like this for Turkey. for instance. So if you are interested in that paper, I can actually I can upload the paper so you can actually read it. So it's a technical paper. It's a bit advanced for you, but you can still read the introduction and conclusion. But such a model of quality quantity trade-off makes a lot of sense for Turkey, right? Because we observe something like this in a country like Turkey when incomes are getting larger and fertility is getting lower and education, people with higher education, the share of people with higher education is increasing as well in the very long run. So this type of a model is rather successful in explaining fertility transition, but also explain, of course, how human capital is actually accumulated. All right. So the key thing, of course, is this technology of human capital production. Now, I want to talk more about this. One thing that I should say is this. So this is from Delacroix and Gosserias paper, 2012. So in that paper, these authors work with a very simple version of this technology. So it is a Cobb-Douglas technology, and it has this form. Okay, so tau is positive, eta is between 0 and 1, and nu is also between 0 and 1. Okay. The assumption is that eta plus nu could be less than 1 or could be equal to 1. Okay. When you look at it this way, if you take logs, you get what? You get ln tau plus eta ln et plus nu ln ht, right? Now the derivative of ln ht plus 1 with respect to ln et is equal to eta, right? Now, what is the economic meaning of this parameter? Well, realize that the kid, when he becomes an adult, will obtain that income, right? Now, this base income will be a technological constant in most applications. So suppose that this is actually a constant, all right? So then, if you look at the total earnings of the child, what you see is the human capital, okay? So then this becomes lifetime returns on education spending, right? Eta is the lifetime rate of return on education spending. So your parents spend ET dollars, your parents spend ET dollars on your education, and that amount of money creates a human capital for you, okay? Now the elasticity of that effect is equal to eta. So suppose that eta is equal to 40%. What does it mean? Well, if you increase your education spending for your kid $1%, right? Then you create a 40% increase in your kids' human capital. and income. Now, this rate of return on education, so this is of course a lifetime return, right? Because ln HT plus 1 is the lifetime income of your kid. Labor economists use that concept in a very distinct way, and they want to understand the rate of return on schooling, okay? And here is the idea. They run a regression okay, so they have people in the sample. So these are individuals, individual workers, let's say. Okay. I indexes workers. And they run a regression like this. You can add other variables and eventually you have an error term, right? Now there are, so here wage is in, let's say, dollars, okay? Schooling is in years, okay? Age is also, of course, also in years. Same is true for experience. Okay. Sector could be a categoric variable. Okay. Sector 1, sector 2, sector 3, dot, dot, dot. Marital status could be 0, 1 as a dummy, so married, non-married, etc. There are, however, a couple of problems here, right? So first of all, let's look at the main parameter of interest, the return to schooling, right? So ln wage I, the derivative of this with respect to schooling, is equal to beta 1. So this tells you one additional year of schooling creates beta 2% increase in wage, right? Because this is a log linear model, right? So this part is log, this part is linear. Remember this from econometrics. But there are some problems, and I'm not gonna dive into all these problems. But for instance, age and experience are related. So age, schooling, and experience are also related because in your lifetime, you are a kid here you are in school, then you work, right? So schooling, work, and childhood. So your experience, it starts here. So they are correlated, so you have to be careful with this. But the biggest problem is that schooling is not exogenous, right? So you have to find a way to use a method other than OLS. And there are different ways of doing that. Oh, B1, I am sorry, thank you. So this will be B1, not B2, obviously. This is, oops, this is B1. There is a large literature on this, but this is a very important concept. So if you write a model like this, so this is a regression model. So if you have data of a large number of workers, right, you can actually study it. So if you are into such interesting research questions, you can check, you know, the literature. There could be many other papers. There are very nice papers by our very own labor economists in Turkey. The important thing is that such a framework is useful for understanding whether the returns are high enough or low enough. So what determines these return rates, etc. Now, let me go back to my production function approach now. In the production function approach, you can now write education spending by parents, education spending by the government. Okay, so this is education spending by parents. This is education spending by the government. This is, let's say this is family J, okay? This is the human capital of parents. This is the human capital of the teacher, okay? And this is the average human capital of the society, okay? And you can add other stuff as well, okay? So this is human capital of the parents. Let's say average of mothers and fathers. This is the average human capital of teachers. And this would be the average human capital of the society. Okay? And furthermore, that production function can depend on the city they live in or the region they live in, okay? Because some regions could have better school, some districts in a city could have higher quality infrastructure in education, so on and so forth, okay? So understanding the problem of human capital accumulation is overall a very difficult subject because it is always a proxy, right? It is always a proxy. Now, if you have no urgent questions about this, I'm going to show you one last thing and then we're going to be done. When we think of education, we of course observe different education categories, right? High school, college, masters, PhDs, right? And then there are some people that are less than high school. There are some people that are less than college. And there are perhaps some people here as well, right? So they continue to postgraduate studies, but they don't finish, they don't complete it, right? Less than, let's say, PhD. So among these different categories, we observe, of course, wage differences, right? So for instance, if you index them by 1, 2, 3, 4, 5, and 6, typically what you would observe that the average wage in the sixth group would be larger than the fifth, and that goes on. These are, of course, averages, right? Averages in all of the people who have high school education, averages of all of the people who have less than college education, averages of all of the people who have college education. Now, economists are especially interested in understanding the wage differences, right? So, for instance, what we call the college premium is this. Roughly, we look at the average wage of college educated people divided by high school and less than college, let's say. Okay, so that gives you the idea of what would you get in terms of human capital if you continue your education to a higher level, right? So in Turkey, for instance, if you look at the household labor force survey, so you can see the education categories of people of these, all of these people that are surveyed. So you see the education categories and you see the earnings. So you can actually calculate such stuff in Turkey as well. Now, I'm going to mention a particularly interesting issue that we observe in the United States. Okay. This is also discussed in detail in Weil's textbook, okay? So this data starts at around 40s and ends at around 2010, okay? So 40s and 2010. In the first graph, here I have the share of total hours worked, okay? And here we have the college premium. So college premium is basically this, right? Less than college, let's say. So what we observe is this. So the labor share in terms of hours worked of people with less than college education decreases, and not surprisingly, the share of hours worked by college educated people increases, okay? Now, we also observe the wage premium to be something like this, evolving in US economy. Let me look at, so it is something like that, okay? So what do we see here? This is a relative price, right? This is a relative price. And this is the equilibrium quantity of labor, right? For two different education categories. So most people look at this figure and they get confused because they, they're confused about what is supplied labor and what is equilibrium labor, right? So here, we observe, at least for that period, so look at that period, okay? Look at that period. We observe that the share of college-educated people increases in terms of total hours worked, and less than college decreases. But in the meantime, we also observe an increase in the college premium, right? So how do we understand that? It is kind of surprising if you, again, confuse this with the supply. But the thing is that even if supply is increasing for the college workers, or relative supply of college-educated people is increasing, right? And the relative price is also increasing. Well, how can this be possible? So suppose that this is any market, so this is price, this is quantity, right? So you observe something like this. So if initially the market is in equilibrium, now you observe the price is larger, okay, but supply is also larger. How do you observe that? So price will be larger and quantity is also larger. Well, and in the meantime, supply is getting larger as well, okay? So you have to shift the demand, okay? Demand has to shift. So the question becomes, why the relative demand for college-educated people increased? Why the relative demand for college-educated people increased? Okay, and there are two reasons, two big reasons. One is globalization, and the other is skill-biased technological change. Now, what are these? Globalization decreases the relative demand for uneducated people, right? Why? Because imagine this is American economy. When the U.S. economy start trading with countries such as China, Indonesia, India, and Cambodia, those countries, of course, specialize in labor-intensive goods. Okay. So if U.S. is increasing trade relationships with these labor-abundant countries, U.S. itself is specializing more on capital-intensive goods, right? So they don't produce clothing, for instance, because clothing is relatively more labor-intensive compared to airplane industry, right? So if you want to produce airplanes, you need mechanical engineers and aerospace engineers, etc. So globalization itself seems to have affected the relative demand for college-educated people, because they decreased the demand, the absolute demand for people with less than college education. The second reason is skill-biased technological change. So the data shows us that most of the technological change for this period, especially after the World War II, is benefiting people with higher skills. So there is a complementarity. So technological progress is not uniform. So we're going to discuss some of these issues in the next weeks, but we understand that different types of technological progress affect different types of skills, right? Some of the new technologies are skill biased, so they increase the productivity of the skillful workers, and some of them basically skill replacing, right? It's because some technologies replace some workers, right? Such as the case in the automation, right? So right now it is very popular. So because of these two big reasons, the college premium and the share of different types of workers in the overall labor composition changed. And that was, again, also a very lively literature. It still is. But when we think of education, we have to consider such determinants as well, okay? Globalization and trade with labor-abundant countries and skill-biased technological change. In the upcoming weeks, again, we're going to discuss more specifically, directed and undirected technological change. and automation issues as well. For now, let me stop. So if you have a very quick question, I can answer it. We have a limited time now, or we can join again for a discussion. Please respond quickly. If you have no questions, I'm going to see you next week.
İyi günler hocam. Teşekkür ederiz.
I'm all done. So okay. I've given you the exercise. Solve it. Think of the issues that we discussed today. Next week we're going to switch back to our technology discussion. So we're going to start analyzing technological progress, and we continue with many different interesting stuff. Okay, take care of yourselves and have a nice week.
İyi günler hocam.
Okay, bye-bye.